Alright, so in last we talked, I was talking about logical expressions and how they're evaluated inside of C. Well, we have an easier way to do this inside of BC if you just want to see. BC and C are very similar in how they handle logical expressions. So, if I ask, is 3 greater than 4? The answer is 0. That's false. Is 4 greater than 3? 1. It's true. So any logical expression can very quickly be tested if I have a value a and I set it equal to 5, and I have a value. By the way, you should terminate statements with semicolons. However, in the case of a interactive prompt like this one where it's really hard to actually enter in multiple statements inside of BC, you don't really have to, but it's considered best practice. So I'm kind of lazy about it because I'm just typing stuff in, but theoretically you should. Anyway, b equals 6. So now I can ask it, is b greater than a? Yep. Is a less than b? Yep. Is a greater than b? No. Now what if I want to test multiple expressions? Well, I can ask it a greater than b and b equal to a value of 6. The answer is no, because a is not greater than b. If I press up on the arrow key and change this now to that, now it's a 1. It's true. What if I ask if a equals to 5 or a is greater than b? I get a 1. Why? Because the left-hand sign is true. Even though a is less than, or excuse me, a is less than the value of b, the or statement still turns out to be true. If instead, though, I say if a is not equal to 5 or a is not, or excuse me, a is greater than b, it's false. So testing any logical expression in BC is very, very simple. So if you just want to test a logical statement, using BC is a great way to cut down on a lot of wasted time. Okay, so the next thing that we're going to get into, and let me just go ahead and pop this up. And I have this GNU.org, and where it goes into the BC, it tells you a lot about how to operate BC. So it's very useful if you are testing BC. Anyway, the logic control statement. So we know how to use and, greater than, less than, blah, blah, blah. Hopefully none of that is a mystery to you. The next big thing to do is to look at how to control testing logic to find out what we should do if something happens to be true. All test conditions assume if the condition is true. If you want to set it to be testing if it's not true, you have to use the unary negation statement, which is the exclamation mark. So here I'm saying if condition, the form of an if statement is if the condition equals true, then begin executing statements. You don't actually need this portion. If you just put in the condition, it automatically assumes by default if the condition is true. And a testing condition is true if it's any non-zero value, because of how C handles true and false, and then execute statements of braces. Otherwise, nothing happens here. And the two ways of finding out if something is true and how it should work is you can either hand trace it or you can use BC. This is where BC is a little bit wonky when it comes to how this works, but I already have some stuff, so I'll say if A is less than B. Then I use my semicolon statement, and then I'll say 1 semicolon. Oops, something went wrong there. That's a terrible demo if it goes off on me. Yeah, because that went haywire, that didn't quite work out right. Anyway, let me pop open BC again. So, A equals 1. If A equals 1, print out the value of A, then I'm going to print out the string. Yep, it is a 1. And then terminate the statement. Here's where things are kind of weird. Crap. Okay. And that is that BC doesn't have the concept of a new line. Now, I'm not entirely sure why this is, but in grand theory, you should be able to use the \n, the escape sequence, and it should not print that. It should understand it once you want a new line, but for some reason in BC that doesn't quite work. it'll just print out the new line, or it'll tell you it's an illegal character if you try using it outside of a string. So there is that one little quirk, and that is how it handles new line returns. But other than that, I just now tested the if condition. So if a equals 1, it does it. What if I instead go back up here and say if a equals 2? Run that. Absolutely nothing happens. Because a does not equal 2, it completely ignores everything within the braces. Alright, there is also the if with else. And the way this one works is if a condition is true, I want to do this. Else, which means pretty much the condition is false, then I want to do this. Again, inside of BC, if a equals 2, do something, else a does not equal 2. And right there it prints out a does not equal 2. So first it looks for the if condition, then it looks for the else, finds it, and it says nope, that is not true. So that's how an else statement works. It just simply is what do you want to have happen in case your true condition does not run. The next thing, the nested if with else if. The way this one works is first you say if condition 1 is true. You don't need this portion again, so you can just say if condition 1, execute these statements else if. So this is now allowing you to test a second condition. And if that one evaluates to true, do this. And then if they both fail, you can use the else statement to terminate it. The key thing here is that if you put just an else in here, the else if will not evaluate. It will give you an error. It must be if, else if, and then finally else. So just so you know that. So to see this, why don't I just write one straight up from start. So else if.c. At this point the very familiar include standard input output.h int main void, and we're up and running. Alright, so I went int a and I'm going to set it equal to 5, int b equal to 6, int c equal to 7. So, in fact I don't need any of that now that I'm thinking about it, but I'll just go ahead and run this. If a is greater than 5, print function, a is greater than 5. Else if, oops, I need to specify the condition, a equals 5, printf, a is equal to 5. Oops, I don't need that semicolon, and I need to put in my new line character. Excuse me. If, just in this case, whenever you're dealing with multiple braces, I have a tendency to indent them just so that way they separate from the main brace. I need to pull this one back so that way they all line up, so all of my statements line up with where they end inside of here. Alright, let's save it. Let's compile it. Alright, now that it is successfully compiled, I'm going to execute the code, and it says a is equal to 5. So here I don't need an else statement to terminate this, I just need to make sure that I don't have an else before the else if, otherwise I'll get an error. But if a is greater than 5, print this, else if a equals 5, and of course, if I wanted to make sure I had all conditions accounted for in this case, my else statement would be something like printf. The only thing it could be is a is less than 5. That is the only possible thing left. So now I've tested for all conditions. Now the downside to using the if statement is that semantically it's very clear what it does. If this is greater than that, do this, else if this is true, do that, else nothing in here is true, then do this. So semantically, at least as far as the human language is concerned, that makes a pretty decent amount of sense. However, the far more difficult character to use is the switch statement. And the way the switch statement works, include header is first you say switch, then you specify what it is you want to test against. In this case, it is the value of a that I would be testing against. Then you have a set of braces that envelop the statement. Then you say case, and then in this case, it's case 5. By the way, if you do this, that is different than 5. 5 is the integer, without the single quotes around it, is the integer version of 5. If you remember, whenever we looked at the ASCII characters here, the character 5, which is on your keyboard, is something totally different. In that case, you're actually inputting the value 53. So if you have it in strings, it will actually evaluate to 53, not to 5, as you probably expect it to. So if it's 5, what do I want to have happen? Well, I'm going to print out the value of a is 5. And then I'm going to use the break statement. What break does is, I'll have to demonstrate this with a few more lines of code, so I'll pause this. Alright, so I went ahead and filled out a bunch of different cases. So first I'm testing a, and I'm switching it out and testing each of the different cases. So in case a is equal to 5, I'm going to print out the value of a is 5. Then it's going to break. If it's 6, it's going to printf the value of a is 6. Now right here I did not include a break statement. So what's going to happen is the code is going to fall through. And what's going to happen is it will just simply print out both this one and this one if the case equals 6. Now, sometimes programmers mean for that to happen. You see in my little thing here, that's where I talk about gotchas. And one of the first gotchas with the switch statement is that switch can only evaluate the condition of either an integer or of a character. And as you should have heard me repeat repeatedly, a character to C is just a number. And I demonstrated that in one of the previous videos. So it only understands really integers or chars, or chars, or however you want to pronounce it. So you cannot try to evaluate a string. Now in other programming languages, yes, you can evaluate other things besides integers and characters. But in C, those are your two caveats. It will throw you a compiler error where it will warn you that only the type int is allowed to be evaluated. Alright, so we have it. I already ran this code, but once again, because the value of a is 5, it simply prints out 5. What if I say a equals 6? Well, recompile it, rerun it, and because you forgot the break statement, the code fell through, and then it says you broke it. So, you can see all 3 lines executed. First this case 6 ran, and it says the value of a is 6. Then the printf ran, and it says because you forgot the break statement, the code fell through, and then it finally fell through to the default where it printed it out. So you have to be really careful when you're writing these that you include your break statement. You don't need one after the default though. That is the one time you actually do not need a break statement, and the reason why is because there's nothing for it. The default is the final statement, just like the else statement is inside of the if-else-if statements. The default is the final one. I think you can put break on it. I don't think it's going to harm anything. Let me test and see if I get an error. Nope, it doesn't really harm anything. But now I run it and the value is 6. It doesn't fall through. Just to have fun, let me show you this, just to prove it. I'm now evaluating if they input the character 6, not if they actually have the integer 6. So let's see what C does with that. It just says you broke it. Because these two are actually different values in the memory of C, this one does not evaluate to true. So that's the if, the else if, and the if with an else statement, blah. There is inside of BC, at least as far as I'm aware, I was looking through it, and it doesn't have the concept of a switch statement, at least not that I can see. Maybe someone who's more familiar with BC can tell me. But as you see, like everything you can do inside of BC is on this one little page, and that's what makes it very powerful and useful to evaluate expressions and see if your logic is correct, because there's really not that much you can do with it. And so whenever we get into the for and the while loops and things like that, we will return to BC to see how it can help us solve these problems.